Which of the following equals 15 choose 7? This time I will do something that is perhaps unconventional. That is, I will immediately choose the answer. So if you were here for the answer, there it is. That is the answer. Why is it like that? It just is. It's a formula. What else can I say? So if you would like to have n plus 1 choose k, you write this as n choose k plus n choose k minus 1. So you see here, in this example, we have n is equal to 14. So when we add 1, we get the 15. And k is equal to 7. So you have n choose k is 14 choose 7, and n choose k minus 1 is 14 choose 6. But what does this really mean? What does this really signify? If you don't want to find out, you could simply end the video here and just remember this as being some binomial formula that you have to put in your list of formulas. Alternatively, you could spend a few more minutes in this tutorial and perhaps you could make sense out of it. For this, I would, as I usually do when I talk about combinations, go back to the Pascal triangle. And maybe I'll write the first 3. I don't think I need to do more than that. So you could think of this as some mini example. We already know how to number this. We start from 0. Of course, it goes on. And regarding the numbering within each row, it doesn't matter if I do it from left or from right. Because it's symmetric. We've talked about that. And I would like to recall how we precisely construct each row in the Pascal triangle. So we have agreed that if I choose this number, it should signify the corresponding n and k. In this case, it will be 1 choose it would actually be 2 choose 2 because I misdrew the Pascal triangle. Can you imagine? It's 1, 1, 1, 1, 2, 1. But it's good. Yeah. We can all make mistakes. That's important. So this is how we've constructed it and how we've agreed to build a row over row is by looking at the upper 2 neighbors and adding them. For the sake of illustration, I will take this number 2. So this number 2, which I will circle in purple, is what? It's 2 on one hand. On the other hand, it's on the third row, so n is equal to 2, and k in our case here is equal to 1. Now we see there's an addition that happened here. What is this addition? It's the addition of 1 and 1. What are those 1 and 1s? I will circle them in perhaps green. So the first one on the left is, you have n is equal to 1 in both of them, it doesn't matter. And one of them is k is equal to 0, one of them is k is equal to 1. And that's effectively what's happening. 1 plus 1 is equal to 2. Wow. Is this really what I'm trying to get at here? Well, the answer is no. This is just one example. Out of many, in a sense, what I'm really aiming at here is to say that this formula, if you compare it here, you'll see that it immediately applies. And the way we informally proceeded is by adding the upper two neighbors. We always added the upper two neighbors. So in a sense, you could say that this formula that we have here is a formalization not in terms of making a formula, but in terms of making it precise. We make it precise that the upper two neighbors will always be these two combinations. And we will always add them to get the next element in the lower row. So that is really what we're aiming at. So more generally, so as you can see here, 2 is 1 plus 1. 1 is, well, let's say if 1 is some k. Then here I have this 1 minus 1, which is k minus 1. The number n is the same. Notice that if you look at n choose k minus 1 and n choose k, they will always be on the same row because they have the same n on top. And they're always neighbors. They're always going to be neighbors. So k minus 1 and then k. So they come right after each other, regardless of whether you count from, you number them from left to right or from right to left. So that is really what we are aiming at here. This is one example. And if I could write down the, well, in this case, 15 rows or 16 rows of the Pascal triangle in order to show you that if I want to write 15 choose 7, I will get 14 choose 7, 14 choose 6, then I would happily do it. But unfortunately, I don't think we have the space for that here. Or the time, honestly. But what I will say very, very vaguely is that perhaps this is not so vague. So you have 14 choose 7, next to it is 14 choose, I think it was 6 and then it was 7. It doesn't matter if you're going from right to left. Let me deliberately do like this. You have terms on the left, you have terms on the right. And n here is equal to 14 clearly. Now, if I add these two, and this is really what I'm aiming at, I go to the next row, which is something we've, I think, universally agreed on now. You'll get 15. Perhaps there is some debate on whether this should be 7 or 6, but in the end it will be 7. In a sense, because if you look at the elements on the rightmost side or on the leftmost side, it's always going to be ones, and this kind of roughly explains it if you already know what we're talking about, but it doesn't explain it well. So all I'll say here, at least for this part, is that you should trust me on it. Or you could alternatively write all 15 rows or 16 rows, 0 to 15 of the Pascal triangle, and make sure for yourself that in the end this 15 choose 7 is what we're aiming for, and that it is indeed the addition of these upper two neighbors. I'll leave that for you.